Okay, I don't know if you can hear me, but this is motion graphs. This motion graph PowerPoint is directly off of my website. I want to go over the motion graphs in preparation for your midterm. It will be a significant part of your midterm relative to the total number of concepts that are on the midterm. Okay, here we go. Now this is a distance time graph. Even though you can't see the label on the x-axis, it is time. It goes up increments of 5 units or 5 seconds. We have a distance going up units of 10. Now, so this is actually quite enclosed. I mean, you have it going up until 60, distance of 60, and then coming back down to 0 at about 29 seconds. Okay, now. So this is a velocity graph. Distance time graph is something that calculates velocity. This is not a velocity time graph. This is a distance time graph. But as you'll see in the first, when you see the first line going from 0 to 5 seconds, going up from 0 to 10 meters, the meters over seconds, the distance divided by seconds is actually velocity. All right, so it's going to be distance versus time. That's the graph. Now, the slope is going to be delta y over delta x. That's going to equal v, or delta v over delta t. The first one is going to be plus 2. The plus represents that it's a positive slope. The plus represents that it is a positive slope. The next one is a slope of 0, and that slope of 0 says that it is, Professor Wall, what's going on at between 5 and 8 seconds?
It's not going up.
It's not going up, it's not going down. What is the person doing if that was a person originally walking plus 2 meters per second? What are they doing between 5 and 8 seconds? Anybody?
Stopping and standing?
They're stopping still, stopping and standing, hanging out, okay? Then at 8 seconds, they start up again, and now they're walking a little faster. They're walking 5 meters per second with a positive slope. And as we go up, again, if it's horizontal, means there's no slope, where the slope is 0. Change in y over change in x. There is no change in y. The change in y is 0. 0 over any number is simply 0. And then it goes up. Again, now this is going very, very steep. If you look at plus 2, plus 5, plus 10, you see how that's becoming steeper and steeper. The more vertical the line becomes, the larger the slope becomes, where if it was a vertical line, the slope would be infinite. Correct? It would be infinite. Now, why can't we say infinite? Because infinite is undefined. I like to say infinite is undiscovered. Infinite exists. Did fire exist before we discovered it? Yes. Did North and South America exist before the Western Europeans discovered it? Absolutely. So I like to say that instead of undefined, it's undiscovered. Okay, that's 0 because it's flat, horizontal, and we go down and we continue. Notice the negative slope for the time frame 20 to 23. That's negative, and 26 to 29. The graph ends at 29 if you look at it closely. Now, this is a velocity time graph, a little bit different, but you can see it's the same shape of graph. I purposely made the exact same graph, but instead of saying that the y-axis was distance, the y-axis is velocity. And it's going to be an acceleration graph. In other words, the lines, the slope of the lines determine whether or not something is accelerating, decelerating, or simply going at a constant velocity. So it's a actually velocity time graph, and the m, or rise over run, or change in y over change of x, will be delta v over delta t. The first slope is going to be plus 2. The first slope is going to be plus 2. and that means that the acceleration is going to be plus 2. The acceleration there is 0, meaning that it has a constant velocity. And we're going to go up the same exact way. So notice the negative 10 and positive 10. That means that it is decelerating, or the acceleration is negative. Acceleration, like velocity, can be a vector where you have direction as well as the magnitude. Next, we're going to look at average velocity. We're going to be looking at, given a velocity graph, a velocity time graph, let's find out what the average velocity is for each segment, and only each segment. Okay? So, velocity time graph, the average velocity is the initial velocity plus the final velocity divided by 2. So all values in this quadrant have a positive average velocity. Why is that true? Because if all x and y values are positive, and you're going to be adding y values together, those are going to be your velocities, and all those y values are positive, then the answer must come out to be positive. Okay? So that's going to be plus 5, because you have 10 plus 0 divided by 2. That's going to be 10, because it's going to be 10 plus 10. Look at the beginning and end of each segment. That's going to be plus 20, because it's 10 plus 30. Okay, 10 plus 30. Is that right, guys? 10 plus 30. I think that might be 15, huh? That's 30. That's plus 45, because it's 30 plus 60 is 90. And then that's going to be 60. It's going to be what? It's going to be horizontal, correct? So it's going to be the beginning of the segment plus the end of the segment is going to be plus 60, and then plus 45. You see, it's not a slope. It's just average velocity. It starts at 60. It ends at 30. 30 plus 60 is 90 divided by 2, correct? And you go down, 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 and that's the end of it. Okay, so verify those values. See if that one 30, oh, I see the 30. The 30 is that horizontal. Check out the 20, though. It goes from 10 to 30 would be 40. Yeah, 40. 30 plus 10 is 40 divided by 2 is 20. Yeah, that is correct. Okay, now, this is going to be a velocity time graph and total distance. What I'm going to do is, I'm going to stop this video, and I'm going to go on to, I'm going to stop it and do another video, because I think I'm going to run out of juice. Okay? So we'll start the next video with the total distance of these curves. Is that okay?
Yeah.
Good. As they say, absolutely.